Okay guys, we've got one more little piece of business to get through to finish up this unit on solids that we've been talking about. And this one today is on scale factor, which is really old news for us. We're going to look at it in a little different light. First of all, scale factor, we know what that is. Here's two segments. One is 2 units long and one is 5 units long. So the scale factor there is just 2 to 5. Now I'm going to make that into a square, a 2 by 2 square, 5 by 5 square. So now if I look at the ratio of their areas, remember ratio is just a fraction. So the area of the first square is 4. The area of the second square is 25. Now let's put that into 3 dimensions. Here's a cube that is 2 by 2 by 2. Here's a cube that is not terribly well drawn, but we'll go with it, 5 by 5 by 5. And this time we're going to talk about the ratio of their volumes. The volumes of this first cube, 2 by 2 by 2, is 8. The volume of the second cube is 5 times 5 times 5, 125. Okay, all of that's old news. But let's look at it together. So here's my scale factor, 2 to 5. Here's my ratio of areas, 4 to 25. Now remember that area is always measured in square units. So like my classroom is 300 square feet. So always area is always in square units. And the volume was 8 over 125. And volume is always measured in cubic units. Like my glass will hold 3 cubic units of water. So volume is cubic. Now look at how they relate to each other. If I took my scale factor and squared it, I got the ratio of areas. If I take my scale factor and cube it, I get ratio of volumes. So we could come up with a handy little chart that says if my scale factor is x over y, then the ratio of my areas is x squared over y squared, and the ratio of my volumes is x cubed over y cubed. All right, let's put that to work. 2 spheres have a scale factor of 1 to 3. The smaller sphere has a surface area of 16 pi square feet. Find the surface area of the larger sphere. Now, I'm not going to get my formula sheet out because I really don't need it. All I need, I'm going to write my cheat sheet here, is this little business that we just talked about. So there's scale factor, ratio of areas, ratio of volumes. So here we have a scale factor and we're talking about area. So I'm going to take my scale factor, 1/3, and I'm going to square it. There's the bell. The smaller sphere has a surface area of 16 pi. Well, 1 over 9, the smaller one's going to be with this 1. So I'm going to say that equals 16 pi. And then I need to figure out the area of the larger sphere. Now, cross multiply, and x equals 9 times 16 is 144 pi. So I didn't even have to look up the formula for a sphere. I just used this fact about ratios. Number 7 says 2 right cylinders are similar. Their surface areas are 24 pi and 96 pi. What is the ratio of their volumes? Well, I'm going to make a ratio here. 24 pi over 96 pi. And let's reduce that. Let's see, off the top, I know those pi's are going to cancel. 24 goes into 96, 1/4. So 1 over 4 is how that reduces. Now this is the part where you can get lost. That's the ratio of areas. So if they give me the ratio of areas, I know that's really just my scale factor squared. So I need to figure out my scale factor. So if I take the square root of 1/4, I'm going to get 1/2. So that's my scale factor. And now to get their volumes, I'm going to take my scale factor and cube it. So 1 cubed is 1, 2 cubed is 8, and that is the ratio of their volumes, 1 to 8. Let's see. Here's another sheet. This is just kind of a chart. Let's see, we know our scale factor is 1 to 2. solid A and solid B. Notice they don't tell us it's a cone, it's a pyramid, it's a cube. They just tell us it's a solid, and that's all we really need to know. So if our scale factor is 1 to 2 and the surface area of our smaller solid is 64 square inches, what's the surface area of our larger? Well, here's my scale factor, 1 to 2. So the ratio of areas must be 1/2 squared, which is 1/4. And I'm going to set that equal to 64 over x, and x must equal 256 square inches. Now to find volume, here's my surface area. To find volume, I need to cube that, 1/8. So that equals 28 over x. And let's see, x equals, handy dandy calculator, 8 times 28, 224 cubic inches. Let's do one more. Okay, so 36 over 324. Now that's surface area, but I want to reduce that. So let's see. I know 36 goes into itself once and into 324 9 times. So this is area. Well, work backwards to get scale factor. I'm going to take the square root of each of those and I get 1/3. So first of all, scale factor is 1/3. And now ratio of volumes. To get volumes, I need to cube, so 1 over 27 equals 12 over x. So 27 times 12, 324. So x equals 324. So you just have to maintain, remember where you at. You have scale factor, are you on ratio of volumes, ratio of areas. I will put up a worksheet for you to look through and try some of those problems, and I'll also put up the key for it.